Yes, very good morning, students. This time we are meeting again for those who are receiving these videos on differential equations. This is a linear differential equations with constant coefficients. We are doing here lecture number 5. It is lecture number 5. I have quoted some examples here. Some questions I have given you here. These are the questions of this different books. These are from different books, the examples that we have quoted here. Let us go to the solution. I will take the first question here. It is a solution to one. What is one question? You have to solve the differential equation with constant coefficient and right hand side is 0. It is 9 y triple dash means third derivative with respect to x, we shall take it, plus 3 y double dash minus 5 y dash plus y is equal to 0. We have to solve this differential equation. Well, we write this differential equation in the form. It is 9 d3y dx cube plus 3 d2y dx square minus 5 dy by dx plus y is equal to 0. Let us write it in symbolic representation. What is the symbolic representation for this? It is symbolic representation will be, it is 9 d cube plus 3 d square minus 5d plus 1 into y is equal to 0. This is the symbolic representation of this. So after writing the symbolic representation, what we do? We write the auxiliary equation of this. So it is auxiliary equation. Auxiliary equation is 9 d cube plus 3 d square minus 5d plus 1 equal to 0. Now you have to solve this for d. It is a cubic in d. Remember, we have different methods for solving cubic equation. One of them is the coordinates method. For biquadratic equation, we use the Descartes, but we will not apply here. It will be a lengthy one. What we do is we go by inspection method. It is a random act. We use d equal to -1, then 1, then -2, then 2, so on. We easily get the result, which one satisfies it. If we use d is equal to -1, let us see here. It is -9. This is plus 3. It is -9 plus 3. It is plus 5. This is plus 1. Yes, d is equal to -1 satisfies it. You see how? When we use d is equal to -1, it is -1 raised power cube, it is -9, it is plus 3, it is plus 5, it is plus 1 is equal to 0. It is -9 plus 9 is equal to 0. Yes, d is equal to 1 satisfies equation number 3rd. Since d is equal to -1 satisfies it by inspection. Satisfy equation number 3rd. So we have got one route. How we find out other route? We can apply divide or synthetic division is the best method. We apply synthetic division by d is equal to -1. Applying synthetic division by d is equal to -1. So here we took -1. If -1 did not satisfy, we would try 1. If 1 not, then we would try -2. So you have to, sometimes you will take few steps for its satisfaction by inspection rule, but if you apply coordinates method, that will be a lengthy one. Applying synthetic division by d equal to -1, you look, those of you who have not yet done the theory of equations, so we'll learn here synthetic division. How we do? We write all the coefficients here. If any term is missing, the coefficient corresponding to that term will be 0. Here d cube has coefficient 9, write this 9. Okay. Here coefficient of d square is 3, write this 3. Here coefficient of d is -5, write this -1, then this is constant 1. Then use the synthetic division by what? You will use it by -1, because -1 is the root of this. Use it by -1. Write this 9 here. Then go to cross multiply. 9 into -1, it is -9. Okay, add here this ordinary addition, it is -6. Then multiply this with this, -6 -1, it is 6. Write it here, you will get it 1. Then multiply 1 and -1, it is -1. This is your 0. So this has verified, it is known as remainder. This has, if it would not be 0, then that means d is equal to -1 is not the root. Since it is 0, this is the verification that it has this satisfied the equation. So -1 is the root, therefore the depressed equation will be given by this, the coefficients of the depressed or reduced equation is. So we write reduced equation is what is reduced equation in this case? It will get reduced by degree 1, because you have one root here. It is 9d square, then -6d plus 1 equal to 0. You can solve it by quadratic method or by the by factorization. You can also go by factorization. You can write it 9d square minus 3d if you know the factorization. If not, I will just review. It is -3d, it is 6. Multiply this into this, it is plus 9d square. That is same as when we multiply this with this, 9d square. These are two things that you should get. Now take 9d common, 3d you can take common here. Taking 3d common, it is d 3d -1 common, it is 3d -1 equal to 0. Take 3d -1, you get again 3d -1 equal to 0. So when you take 3d -1 equal to 0, that gives d is 1 by 3. When you take again 3d -1 equal to 0, that gives d is equal to 1 by 3. So you have two roots repeated. So roots of auxiliary equation are -1 by 3, -1 by 3, and they are -1. But these two are repeated. These are repeated. You have to apply for these the repeated case. How you go for the repeated case? You know, you write it y is equal to, you have to introduce two constants, that is c1 plus c2x, as you know. Please go to lecture number 3 where I have explained when roots are real and different, when roots are real and equal roots, and when it has imaginary roots. It is e raised to power -1 by 3x because of repeated root. Then 1 is non-repeated, single root, real root. So for that you will introduce another constant, that is c3. Then you write e raised power this -1 into x. X is here independent variable, so it is -x. This is the complete solution of this differential equation. So this is done. This differential equation is done. Now let us go to next one. I have taken these questions from different books. Some questions are from engineering mathematics, and some are from the this BSc mathematics book. I think I am stressing on more questions, so that because there is a demand from the students who have only the application part of this, not the thermos extra. They will get the applications, that is questions. So I have stressed, otherwise I would direct to go how to find out the integrating factors. So I have taken these questions for you people. Let me have this another question. What is that? You have to solve the differential equation. Solve this. It is d2y dx square plus 4 times dy by dx, 4 dy by dx 4 dy by dx plus 29y is equal to 0. You are given the condition, given x is 0, y is 0, and dy by dx is 15. With this in boundary conditions, these are sometimes known as boundary conditions. With these boundary conditions, you will get the constants, because this is the second order differential equation. It will, in the solution, general solution, it will involve two constants, but with these conditions you will get those two constants. If you use C1 and C2, you will get what is C1 and C2. Well, let us write it as symbolic representation. As you do, it is symbolic representation you write it is d square plus 4d plus 29 into y is equal to 0. Then you have auxiliary equation. Auxiliary equation is d square plus 4d plus 29 is equal to 0. Solve this for d, you will get two values of d. So d is given by minus 4 plus minus under root of, it is 16 minus 4 into 29 by 2a, that is 2. It is equal to minus 4 plus minus under root of, it is 16 minus 616 by 2. This gives you d is minus 4 plus minus under root of minus 100 by 2. Do you follow me? This is equal to minus 4 plus minus iota root 100 by 2. That gives you d is minus 4 plus minus iota 10 by 2. This is d is equal to minus 2 plus minus iota 5. Complex root. It is a complex root. So how you write down the solution? You have the solution. Solution is given by y is equal to e raised to power real part. What is the real part here? Minus 2. It is minus 2x. Minus 2x. Then any constant, let it be c1 cos of imaginary part cos of 5x plus c2 sine of 5x. This is the solution. Y is e raised power minus 2x, c1 cos of 5x plus c2 sine of 5x. Well, solution of this differential equation is now given by y is equal to e raised power minus 2x into c1 cos of 5x plus c2 sine of 5x. Name this third equation. Now I am given use x is equal to 0 and y is equal to 0. What you get? You get 0 e raised power 0. It is c1 cos 0 is 1 plus sine 0 is 0. This gives you 0 is c1. This gives you have got one constant, arbitrarily constant that involved here, c1. You have got it 0 because of the boundary conditions. Now I am given dy by dx is 15. I will differentiate equation number third. Differentiate this. Differentiate equation number third. Differentiate third. When you differentiate this, you will get dy by dx. It is equal to product rule. I will use derivative of this. Derivative of this is power. Derivative of power is minus 2. It is minus 2 e raised power minus 2x then c1 cos 5x c2 sin 5x, second function as it is, then plus e raised power minus 2x as it is, derivative of second function, derivative c1, derivative of cos is minus sine, it will be minus sine of 5x, then plus c2 5 derivative of angle 5, then c2 it is derivative of sine cos 5x into 5. I will write 5 here. Okay, then you have to use now use x0 dy by dx is equal to 15. Let us see what we get when you use it. This is your dy by dx. Dy by dx is, it is minus 2 e raised power 0 is 1, it is C1, cos 0 it is 1, it is C1, sin 0 it is 0, then plus e raised power 0, this is sin 0 it is 0, then it is plus 5c2 because cos 0 is 1. So this is dy by dx, but c1 is your 0, it is 0, plus it is 5c2. Use dy by dx, it is 15 is equal to 5c2, it is 5 3s are, that means your c2 is 3. So what is the general solution? Using c1 and c2 in third. So you will get the complete solution in this case. So solution is, required solution is, y is equal to e raised power minus 2x, but c1 is 0, plus you have got c2 3, it is 3 sine of 5x. So you can write solution is y is equal to 3 e raised power minus 2x sine of 5x. This is the complete solution of this differential equation when we could find out C1 and C2 with the given conditions. When these conditions were given, this is the solution of this. Okay. Let me take one more problem. It is solve the differential equation, which is, it is d2i dt square plus r by l di by dt plus I by LC is equal to 0. You are given something here. Given is R square C is 4L and R, C, L are constants. You have to solve this differential equation. How will you go? Here I is dependent variable. It is dependent variable I. So you can write it is, what is it is symbolic representation. Be cautious. Symbolic representation is this. I can write d square plus r by ld plus 1 by lc I is equal to 0. Your y is now I and your independent variable is t. Be cautious about that. Now what is the auxiliary equation? It is d square plus r by l plus r by ld plus 1 by lc is equal to 0. It is simply quadratic in d. I can solve it for d this way. This is d is equal to minus r by l plus minus under root of, this is r square by l square minus 4 by lc by 2a. This I can write now. 2a is 1, a is 1, sorry, it is 1. This is 1 by 2, 1 by 2, it is 1 by 2 minus r by l plus minus under root of, it is r square. If you write everything in root, r square minus 4l, r square minus 4l. No, l square c is LCM. I will take first LCM. It is l square c will be LCM. L square c is LCM. It is r square c minus 4l. But you are given here that r square c is equal to 4l. That means r square c minus 4l is 0. So this part under radical is 0. Therefore I am getting d as 1 by 2. It is minus r by l plus minus 0. So you get here repeated roots, because plus 0 gives the same and minus 0 also gives the same. So d is minus r by 2l, then again minus r by 2l. It is repeated. So how you write down the solution, dear? You will write solution of this differential equation. It is dependent variable is I. So solution of this differential equation will be equal to, now I is equal to, a repeated root is, it is c1 plus c2. You have independent variable t, c1 plus c2, t is there. Then it is e raised to power minus r by 2l. It is minus r by 2l. T you can write here, it is t. So this is the solution of this differential equation. Because it had repeated roots, so we have to introduce the constant is this way. Our independent variable is here, t instead of x. This is the solution of this equation. This was this part. Let me take another. Now you have to solve this. Solve d4x by dt4 is equal to m4x. But he gives you the result. If you look here, the result he gives in this way. You see, this is the question. d4x dt4 is equal to m4x. Show that x is c1 cos mt plus c2 sin mt. Then it is c3 hyperbolic cos mt. Then c4 sin hyperbolic or sin mt. So I have to involve in the answer what? Cos hyperbolic and sin hyperbolic. You see how we go for it is solution, how we solve it. Now we can write this differential equation as it is d4x by dt4 minus m4x is equal to 0. Writing this in symbolic representation. What is it? A symbolic representation? Symbolic representation is, you can write it is d4 minus m4 into x is equal to 0, where you have d is equal to d by dt. Now go ahead. What is the auxiliary equation for this? It is the dependent variable, t is the independent variable. So you have auxiliary equation here. It is d4 minus m4 equal to 0. You can write this as d square whole square minus m square whole square is equal to 0. It has the factors. It means its factors are d square minus m square into d square plus m square equal to 0. Now this gives you, when you take d square minus m square 0, and when you take d square plus m square 0, this gives d square is equal to m square, that is d is equal to plus minus m, d square is equal to minus m square, d is plus minus iota m. So what are now roots? I will write here. Its roots are now d is 0 plus minus iota m. These are two roots, complex roots, and other two are minus m and plus m. Let us write down its solution now. You see how you write down the solution. Its solution is now dependent variable is here x. You will write x is equal to, corresponding to these two roots, complex roots, how you write solution? E raised to power a real part, that is 0, into t. Then use the constants. I will use here, say c1, imaginary part, it is cos of mt plus c2 sine of mt. Then these two roots plus, I will use here a constant, because in the answer he has used c3 c4, but here two constants will get merged. You will see when I convert the e power in sine hyperbolic and cos hyperbolic. I will write a constant a. This is your e raised power minus mt plus b e raised power mt, where you have c1 c2 a comma b are constants. Actually this is the answer of this question, but he wants the answer in some other way. Let us give the answer in that way. Well, you have now x is equal to, this is e raised power 0, it is c1 cos mt plus c2 sine mt, then it is plus a e raised power minus mt plus b e raised power mt. This is the solution of this, but I will just use few steps more. I am using this result to get sine and cos. This is a very important result. You have this in perhaps in complex trigonometry. You have e raised to power m theta in terms of cos. It is cos hyperbolic m theta plus sine hyperbolic m theta. E raised power minus m theta. Okay, this is sine hyperbolic, sorry, it is here, it is also here, cos m theta minus sine m theta. It is for m theta. If you don't write m, it is here it will be theta, here theta, here theta, here theta. I have used m because of this m here, so that you will not get confused. Now this is x is equal to c1 cos mt plus c2 sine mt, then plus a, I will use this hyperbolic part, it is cos hyperbolic mt plus sine hyperbolic or sine, it is here, yes, minus here mt, then plus b, this is cos hyperbolic mt plus sine hyperbolic mt. Now what I do is I take a cos here, here you have cos, connect this with this, you will get the result. This is x is equal to c1 cos mt plus c2 sine mt, then taking this common from these, it will be a plus b plus a plus b cos hyperbolic mt, then here take common this sign, you will get minus a plus b sine mt or sine mt, because I want the result in terms of hyperbolic cos and sine. Yes, these are again constants, because sum of two arbitrarily constants, again some arbitrarily constant, difference of any two arbitrarily constant, again some arbitrarily constant. That means you have here a plus b, I will choose, let a plus b be c3, and I will choose b minus a is equal to c4, so that I will get that result. Therefore solution is general solution of this is x is equal to c1 cos of mt, then plus c2 sine of mt, then plus c3 cos hyperbolic, it is cos mt, then plus c4 sine hyperbolic, you can say it sine of mt. This is the required result that he wants. Otherwise I would stop there, but he wants the result in terms of cos hyperbolic and sine hyperbolic. We could give its value in cos and sine. I will share some more problems, 2 or 3 problems I will share, so that you will be in a position to do all types of questions in this examination. Now next to this, my aim is to just give you how to find out the particular integral, because when right side of the differential equation is not 0, it is x. X can be function of some variable x. X can be the function, capital X can be the function of, say, sine function, cos function. This is a algebraic function. In that case, we will give the methods how we find out integral, a particular integral, because when we solve the differential equation, in case right side is not 0, we have 2 parts of the solution. One is complementary function. This is the complementary function. You have to go for complementary function in this way. And second part is the particular integral. Now we have to learn in next lectures how to find out particular integral. Then you will get the complete form of this linear differential equation with constant coefficients. Thank you very much. Till then you wait. We will be meeting in next this lecture. Thank you very much.